we start, I'd like to quickly introduce myself. My name is Intania Melati Libna, but sometimes friends call me Amel. I am currently a college student in the 4th semester of Mathematics in University of Lampung. And today, I will present you about mathematics lessons. It's about roots. I begin by looking at the general case of roots until the specific one. By the end of my presentation, you'll have learned about general form, characteristics about roots, and rationalize the denominator. And also, I'll give you exercise about roots. So, if you are interested about this presentation, just keep watching and enjoy this video.
As I said at the beginning of this video, I'd like to start with the general case of roots. Here, we can see from the slide, I will break down this topic to 3 points. There are general form, characteristics, and rationalizing. So, let's move on to the first point. The first point is general form. This is the general form of roots. The nth root of a to the power of m equals a to the power of m over n.
And the second point is characteristics.
And wow, we have 8 characteristics about roots. The first characteristics is m times the square root of a plus minus n times the square root of a is equal to m plus minus n in brackets times the square root of a. The second one, we have the square root of a times the square root of a is equal to a. Next, the square root of a times the square root of b is equal to the square root of a times b. And then to the next characteristics is m times the square root of a times n times the square root of b equals m times n in brackets times the square root of a times b. And then we have m times the square root of a over n times the square root of a is equal to m over n. Next, the square root of a over the square root of b is equal to the square root of a over b. Next, p times the square root of a over k times the square root of b equals p over k in the brackets times the square root of a over b. And last one, we have the square root of a squared is equal to the absolute value of a. For some notes, there are the square root of a plus the square root of b in brackets times the square root of a minus the square root of b in brackets is equal to a minus b. The second, we have a plus the square root of b in the brackets times a minus the square root of b in the brackets equals a squared minus b. And the last one, the square root of a plus b in the brackets plus minus 2 times the square root of a times b equals the square root of a plus minus the square root of b.
So far, we have learned about general form and characteristics about roots. Let's move on to the last point. The last point is rationalizing. It means rationalize the denominator. A fraction expression can be rationalized by multiplying this fraction with the other fractional multiplier that have one value. The numerator and denominator of this fractional multiplier can be same numbers as in the denominator of the original expression or conjugate of the denominator. Conjugate means the same numbers but the opposite sign in the middle. To give you clearly information, just check it out.
To give you an example for same numbers as are in the denominator of the original expression, simplify 6 times the square root of 2 over the square root of 3. How can we rationalize it? If we want to rationalize this expression, we can multiply this expression with same numbers as are in the denominator of the original expression. Because of the denominator of this expression is the square root of 3, so we can multiply this expression with the square root of 3 over the square root of 3. The square root of 3 over the square root of 3 have one value, so if we multiply the original expression with the other expression that have one value, we are not change the original expression value. So the answer for this question is 6 times the square root of 6 over 3. And then for example, conjugate of the denominator. Simplify 2 over 2 plus the square root of 3. As I mentioned before, conjugate means the same numbers but the opposite sign in the middle. So, if we want to rationalize this expression, we will multiply this expression with the conjugate. The conjugate from this expression is 2 minus the square root of 3 over 2 minus the square root of 3. So, if we multiply this expression with the conjugate, we will get 4 minus 2 times the square root of 3. We have to remember that the square root of a, rationalize it with the square root of a. And then a plus the square root of b, rationalize it with a minus the square root of b. Next, the square root of a plus the square root of b, rationalize it with the square root of a minus the square root of b. And the last one, b times the square root of a plus k times the square root of b in the brackets, rationalize it with b times the square root of a minus k times the square root of b in the brackets. So now we have exercise time. Find the solution of this fraction. So, how can we solve this one? We can solve this question just like this. First, we can multiply 1 plus the square root of 2 with 1 minus the square root of 2. And the result is 1 minus 2. And then 4 times the result of 1 minus 2 equals minus 4. So now we get the simple fraction from the equation. It is minus 4 over 3 plus 2 times the square root of 2. From the simple fraction, we can rationalize it by multiply with the conjugate. And then we get the answer. So the answer from the question is minus 12 plus 8 times the square root of 2.
After showing you exercise about roots, this leads me to the end of my presentation. I've covered 3 points about roots. There are general form, characteristics about roots, and rationalize the denominator. Also, I gave you exercises about roots. That's the end of my presentation about roots. That's all I have to present today. I'd like to thank you for taking time out to listen to my presentation. I hope my presentation will help you with what I said at the beginning of this video. Please feel free if there are any questions or comments. I'll be happy to answer them on the comment below. Thank you so much for listening and bye-bye!